explain Rx diagram of Moore relay characteristic. So on the Rx, that is resistance and reactance plane, you can visualize this round circle type characteristic as the Rx diagram of the Moore type distance relay. This relay is a circle that passes exactly through the origin 0, 0. You can visualize this, and this is the line to be protected here, this. Because it starts at the origin, it looks only in the forward direction. You can visualize this. This characteristic is in this direction, that is in the forward direction only. So it will not trip for the fault behind the relay, that is the relay operates only for the forward faults. The relay evaluates the value of the impedance measure Z. Here Z is equals to the boundary of the circle is equals to here this Z. The Z is the boundary, which equals to K1 by K2, that is the value of the constant cos phi minus alpha. You can visualize this. And this Z K1 by K2 can be represented as the reach of the relay, that is impedance of the reach, that is ZR. So this is the boundary, and this radius, this is the circle of the characteristic. So inside this circle it is the positive torque region, and outside the circle it is the negative torque region. This is the maximum torque angle alpha, and this is the power factor angle phi between voltage and current, or say the value of the impedance of the line. To make it simpler, we call K1 by K2 as the diameter of the circle, or say ZR, that is reach of the relay. So the operating equation becomes Z less than ZR cos phi minus alpha, which is inside the value, where Z is the impedance measured by the relay at the given moment V upon I. ZR is equals to the diameter of the circle, the maximum distance the relay protects. Phi, the angle of the fault where the current is relative to the voltage, that is the value of the impedance, or the power factor angle. Alpha, the angle the relay is set to, that is the line's maximum torque, usually matching the transmission line at 60 to 70 degrees. The equation simply defines whether the measured impedance Z is inside or say outside of the circle. Inside the circle, that is Z is less than ZR cos phi minus alpha. So a fault has occurred on the line. The impedance drops, that is falling inside the circle. This creates the positive torque and relay operates, means it issues the trip command. Now outside the circle, that is Z is greater than ZR cos phi minus alpha. So the system is running normally, or the fault is too far away from the relaying zone. The impedance stays outside the circle. This creates the negative torque region, and relay does not operate for this type of fault. So this is the Rx diagram and its interpretation for the Moore type relay characteristics.